Welcome. Thank you for joining our webinar. My name is Jana. I'm the Product Marketing Manager here at Innovatrics, and I will be your host for today. Today's session will be focused on our latest innovation in active liveness detection, and we'll be introducing multi-range liveness detection. But before we jump to it, let me tell you or walk you through the essentials. You don't have to worry about missing any details because this session is being recorded, and we'll be sharing the recording with you in the follow-up email. Today's webinar or the presentation will take up to 20 minutes, and it will be followed by the Q&A session. You can ask your questions anytime during the presentation, and for that, please use that Q&A panel, as you can see highlighted on the slides. While preparing for this webinar, I was looking into the attendee list, and I saw some new names on the list, and that's why I would like to quickly introduce our company. So Innovatrics is an independent biometric solutions provider for governments and enterprises for more than 20 years now. We've been developing our own biometric algorithms, and over that time, we delivered more than 600 projects all around the world. And now, lastly, I would like to introduce my colleague who's going to be the presenter for today. Victor is the product manager for IDV Solutions, and I give the floor to him. There you go.
Thank you, Jana. So today I'll present the multi-range liveness. First, I will summarize the liveness methods that we have and compare it with the new. I will discuss a lot about the UX, how we were designing the new liveness method in order to be easily usable by the customers. I will explain the algorithms, and then I will demonstrate the integration with our toolkit. So at first, let's summarize the livenesses. We have the passive and smile liveness. These two we consider to be passive and semi-passive. For the active liveness methods, we had two up till now. The first was the eye gaze liveness, which was developed many years ago. In this liveness, the user had to follow a dot with his eye, and this was the actual challenge. Of course, this liveness had issues because the detection of the eyes didn't work on all persons because of the their eyelids or similar issues. So we have developed another liveness, the magnify liveness, where the user had to bring the camera closer to the eye to get a close-up details. These two livenesses are now planned to be replaced by the new multi-range liveness. So we have decided to develop a new kind of liveness because we've been listening to the feedback from the market, and we had many customers that were asking that they need to follow a regulatory requirement that the liveness needs to have a randomness factor in it. This was the case with the eye gaze liveness, but not in the multi-range liveness. Also, we have seen on our statistics that these two active livenesses that we have didn't have a good completion rate. That means the rate of the people who are able to successfully finish the capture. So we wanted to do some user experience improvements so that we increase the completion rate of the livenesses. And of course, we wanted to simplify our offering so that the user doesn't have to choose between two different active livenesses. So we wanted to develop new active liveness that would unify these two and finish all the requirements which are requested from the active liveness. I have mentioned the randomness factor. This is where a user must perform a different action each time he's onboarding. This is to prevent any pre-recorded video, and as I mentioned, is a regulatory requirement in many countries. We have made this challenge in order to make it more robust from injection attack. We have made this challenge generated on the server, and it's a different one for each session so that the replays are not possible. When designing the new liveness method, we have three main criteria which we needed to follow. So it needed to have the randomness factor in it. It needed to have a high completion rate, meaning the UX need to be good, and the liveness had to be feasible to be technically achieved with a phone or with a web camera and with the algorithms that we have. So we came to 6 different ideas, and we have created a POC of each one, which we tested in our extensive user experience testing. So we have tested all these 6 methods with a high number of volunteers, which are of different age groups, with different technical skills, so that we know that every customer can fulfill the liveness challenge that we are giving to him. We have found only one method where every volunteer was able to complete the liveness, and this was taking selfie at different distances. It is demonstrated on the video on this slide. So the reason why why it was so simple for them to finish this task is that they have been doing only one kind of task, taking selfie, which everybody is able to, and this selfie was taken multiple times at a random sequence of distances. So this is the new multi-range liveness that is developed. Of course, when you are repeating the same task multiple times, taking a selfie, it affects the time to capture. We have seen that the time to capture with the multi-range liveness is longer. Just our statistics here taken on a wide range of data collected in our analytics, we see that with a passive liveness and smile liveness, the average time to capture is 5 seconds in both cases. With the small set of tests we have done with the multi-range liveness, we've seen that the time to capture average is 15 seconds, and that's understandable because the same task is repeated multiple times. But we consider that the longer time to capture is not that issue if we know that every user is capable to finish it. So that's why we think that this longer time to capture is okay. And of course, the time to capture depends also on the number of the photos which is collected. The multi-range liveness can be configured to capture between 4 and 8 photos, depending on what amount of randomness you want to have. We didn't allow to take just 3 photos because there would be only 8 combinations possible. but starting with 4 photos, you have already enough random combinations to capture, and this grows exponentially. Now, how the liveness is evaluated? Of course, we have there our passive liveness, which we offer as its own kind of liveness. This is evaluated on all the photos that are captured, and there is the evaluation of the challenge sequence from the behavioral analysis. So there is something else collected, which enables us to tell whether the user is following the randomness sequence or not, whether it's a pre-recorded video loop. And the output of the liveness is either 0 in case that the randomness sequence was not followed, or the liveness score, which was evaluated on the photos. So you know that you can apply the same threshold that you have in our documentation for the passive liveness. Now I will explain the integration. So it's very similar to all the other liveness methods that we have. There is just one change. The session starts on the back end, where you need to ask the digital identity service for the randomized challenge. You get that challenge for the active session. When you get the challenge, you have to send it to the mobile or web SDK on the client, which then captures the photos following that challenge and returns the encrypted data buffer that you have to send back to the server where it is evaluated. And now I will do a quick demonstration here. So I will use our Postman collection demo. So first I'll start by creating the customer, the liveness. Now what I'll do, I will ask the server for a random sequence for this session. And I will copy this sequence to, we have here a demo for this, where I will paste the new sequence. So I have changed the sequence, and now I will collect the photos with this liveness. Okay. Now I will download the encrypted data. Let's return back to the server. I will upload this data. It's okay, and now I will evaluate the liveness. And here you can see that the score was not 0, so the randomness challenge was followed, and the score is 0.93, which is well above the threshold. So it's a genuine photo. So this is simply how it works. Now, I have mentioned that this multi-range liveness will be replacing the previous active liveness methods. So the smile and the passive liveness remain, and the magnify and eye gaze liveness both are now deprecated. So if you are now choosing which one to integrate, please don't integrate these two. These two will be still supported till the end of the next year, 2026. So you have pretty much time to migrate to the new multi-range liveness, which I think you will find better than the previous two. And of course, if you won't make it till the end of 2026, that doesn't mean that you cannot use them after that time. It's just we will not provide any bug fixing after this date. And for the resources and documentation, we have in public documentation our active liveness page, where you have all the livenesses documented, and you have here links to the particular documentation of the components that relate to this. So now that was all for my presentation, and we can get to your questions.
Yes, thank you very much, Victor. I'm sorry for an interesting and detailed presentation. I don't see any questions from you for now, so we'll give you a minute or so. Feel free to ask your questions if you have any. Yeah. Okay. What does IDV represent? It's a identity verification. Any other questions?
Yeah, identity verification. Also, probably you mentioned that we are rebranding our product from the DOT. Now the new name of the product is the IDV Toolkit, so IDV Identity Verification Toolkit.
Okay, we have the questions coming. So is the camera with multiple zoom could impact, I guess, whether the multiple zoom could impact the score of the liveness?
Yeah, well, the distances at which the face is captured in this liveness are in the standard range where the camera focus is working, whether it's a zooming camera or not. So there shouldn't be an issue with this. In case that the camera zoom would be slower, the capture component still, as you have seen, each picture is taken for 2 seconds. So there is enough time for the camera to rezoom and take a sharp image.
Okay, next question. Abdullah is asking which version will start to support the active liveness?
This multi-range liveness is already released. So if you will see our changelog, probably 1 or 2 versions back are already supporting it.
And then Isidora asks if it is possible to implement this component on mobile instead of using web.
Yes, of course. We have also native SDK for Android and iOS, and the functionality with the multi-range liveness is the same for all 3, Android, iOS, and the web components.
Next up from Piotr, is the server component mandatory? Is it possible to integrate completely on device?
No, you have to use the server component because the liveness can be evaluated only on the server. And of course, this is identity verification toolkit for remote onboarding where you cannot trust the capture device. Of course, if you are pointing to the question that if this capture component can be implemented in a kiosk device that can be trusted, yes, this could be possible, but it's not in the scope of our product.
Okay, and then Horst would like to explain again the random position part.
Yeah, so what you have probably noticed when I was taking the images, I was taking 4 images at the different distances of my face from the camera. And these distances are randomized. So there are different distances where the face could be captured. And this is put into a sequence. Of course, you never have 2 different distances after each other, because then you wouldn't have to move the camera or your face closer or away. So that's the sequence that needs to be captured of the different photos is always randomized.
Hope that answers your question, Horst. Next up, I would like to know what's the minimum number of steps, as adding more steps it takes a considerable amount of time.
Yes, so currently the minimum of steps is 4, and the average time to capture is 15 seconds with the 4 steps. Minimum time to capture was 10 seconds. So if a user is skilled and knows already the liveness, he can do it in 10 seconds.
Okay, Krzysztof has the question: what's the baseline accuracy of Innovatrics passive liveness?
Yes, you can find in our documentation. I can maybe show this. You can find in our documentation the tables for the passive liveness, where you can find the false accept to false reject ratio. And here you can see that the equal error rate is 1.43%, but that's okay, sorry, we cannot see it because of the questions here. So I'm referring to this table that you can find in our documentation. So the equal error rate is 1.43, but you have to consider that this is on certain data set. And this is our special data set which contains very difficult attacks. So normally in production, you will have much higher precision than what we are measuring here.
Okay, next question, or rather a comment. We intend to reach out for more documentation and evaluation directly, of course. It's more than appreciated. We're happy to see you're interested, so feel free to reach out. We'll be sharing the follow-up email where you'll have the direct contact, but you can, of course, approach sales@innovatrix.com anytime. Thanks. Next up, can you explain the pictures combinations relationship? I guess we kind of...
Yes, that was the table where there was a number of the photos and the number of the possible combinations. There isn't an exact formula to that, because theoretically the number of the combination would be much higher. But from the combinations are removed all the combinations which are not allowed by the algorithm. So the algorithm that generates the challenge has some rules how the sequence has to be generated, and some combinations are not allowed. So that's why the numbers are a little bit different than you would expect from an exponential curve.
Well, next question. What are the FIR to FRR compared to passive liveness and or magnify liveness?
So, as shown, we are applying the same table, but what you have to consider that with passive liveness, you are capturing only one picture where you need to assume the liveness. In this, both in magnify and multi-range liveness, we are evaluating the liveness on multiple pictures. So the attack that, for example, is not visible on one picture can be seen on different picture because the camera is closer to the attacking object or more further from the attacking object. So this is increasing the security and the chance of discovering the attack. And of course, this cannot be mathematically evaluated because that depends on the kind of attack that the attacker is doing. And comparing the magnify and the multi-range liveness, I would say that the change between these two is the success or the completion rate. So how many people are successful at finishing it. So the benefit of the multi-range to the magnify is the higher success rate.
All right. Next question. I guess this is meant or asking about some attack. If an AI software with Zoom enabled, how liveness is justified?
Okay, so if somebody would be using some AI software to emulate a face which is closing or getting closer or moving away, of course the liveness can detect screen attack. There are other checks, the behavioral checks, which check whether this is followed. And there are also some other hidden things inside which would be capable to identify this kind of attack.
Okay. Next up is mobile SDK. Does mobile SDK require online?
Well, the mobile SDK, when it's capturing the photos, it doesn't have to be online, but of course you need to have the device online in order that you can get the challenge from the server. But this is done by the integration that needs somehow to get the challenge to the device. But the capture component, while capturing, it doesn't need to have an online connection.
Mm-hmm. Okay. Next question from Madeline. Multi-range verification alone as an active liveness solution covers all legal requirements so far. Is it correct?
Yes, all the legal requirements which we have found, we have addressed with this liveness. There is also a feature which we presented in a different webinar that this liveness can capture also a video of the process, and this can be extracted on the server. It's a different feature, but this liveness supports that as well.
Mm-hmm. Okay, I guess the next question kind of relates to the previous answer.
Yes, or maybe just repeat.
Yeah, so are the captured photos displayed one by one or as a GIF or consolidated images that can be downloaded from a single link?
Okay, so the server provides you with the option to download one image, the one that should be representative for face matching or creating any records. And also there is the possibility to use the video recording feature. In that case, you have to configure the capture component to record also video. This records the last 8 seconds of the capture and transfers together with the encrypted data on the server. And in that case, the server will return you the video recording, so you can get a normal MP4 video file from that.
Mm-hmm. All right. Next question. What's the volume of information that is sent to the server?
So more or less the size of the images that are sent to the of course, there are some additional data, but they are in tens of kilobytes. And if you enable the video recording feature, then it's 1 up to 4 megabytes additionally. But if you choose to capture just the 4 images, it could be, depending also on the camera resolution, it could be 1 megabyte around.
Another one interesting question, whether the facial expressions have any effect on how the multi-range liveness is evaluated.
No, it doesn't have any facial expression detection. Of course, we were considering to combine the multi-range liveness with smile at some step, but we have seen that this would probably complicate the capture, and there wouldn't be the completion rate so high, so that's why we didn't implement any expression detection.
But I mean, you can always smile while doing this. Okay, next question. Is there a minimum version for Android or iOS to support this functionality?
Well, yes. Please check our changelog to see from which version is this one. Okay, no, you ask minimum version of Android or iOS. Yes, this is communicated in our documentation, so I think we're currently at Android 7 and iOS. I don't remember exactly, but you can find it in the documentation. And all our capture components have the same minimum requirement.
Okay. Next question. Is there any limitation as it comes for the camera pixel size?
Well, all our SDKs, all our capture components work on a common camera that the user can have. So that means that a web camera with 720 pixel resolution is sufficient for this liveness.
And the next one is kind of related to that. What's the minimum camera specification and processor need? And how much would be the data size for each individual?
So I answered already to the minimum camera specification. The processor need, just any hardware is capable for the auto capture components, even the old phones and the desktops, they have plenty of computing power. And the data size, of course, depends on the camera resolution. If it's a 720p, it's the data are a little bit smaller, let's say 3/4 of a megabyte. If it's a 1080p camera, then it can be around a megabyte.
Okay. How robust is the algorithm against AI-generated videos?
The algorithm doesn't detect that it's AI generated. There are 2 ways how we prevent this. Either when this is presented from the screen, then the liveness is detecting that it was presented from the screen. It doesn't detect that it was AI generated, because you could do an attack even with a recorded video of a genuine person. And if the AI generated video would be injected, bypassing the camera, then we have methods for detecting injection attacks. And also we have algorithms to detect deepfake generated images.
Yes, and I think related to this is the question from Dmitry. Can the new multi-range liveness also be evaluated using liveness presentation attack detection, deepfake detection, and video injection detection? I guess we already answered it.
Yes. All these are combined together. So yeah, or you need to perform all these steps, and our toolkit provides them.
Yeah. Is the question from Alejandro, is the algorithm based on the complete images or only in the detected landmarks? How large is the encrypted message that needs to be sent to the backend?
Yeah, the size of the message sent to the backend was already answered. So it's around 1 megabyte or below 1 megabyte.
Yeah.
And it considers the whole images captured.
Okay. We have last couple of questions. When performing liveness on mobile, the system requires the user to move the device quite far away, almost at full arm's length. Is it possible for us to adjust the distance so the user can hold the device closer?
No, but the selection of the distances was designed so that anybody can achieve that. But there still needs to be some set of the distances need to be there needs to be a difference in the distances, which is sufficient enough for the algorithm to detect the difference, and the user should be always able to capture it. It will not happen that the distance is so far away that the user cannot perform it. And yes, it's not adjustable because of the way how it's designed.
Okay. Christoph has a question whether a customer can implement our liveness backend server on their premises.
Yes, we offer both on-premise installation and cloud hosting.
Yeah. Is there any built-in protection in the SDK that captures the photo to prevent the use of a virtual camera or other mechanisms like video injection or malware, or are there protections handled exclusively on the server side?
Well, it's both client and server. The clients, our video injection detection feature ensures that the client, the SDK, captures all the data necessary to identify whether there is an injection attack, and the server is evaluating the data from the client to identify the injection.
All right, then. We have a lot of questions here. I'm not sure if we have enough time to answer them all. If not, then we will definitely answer them from the desk and contact you directly. So maybe we can answer one or two more. For example, this one from Mieveni. Will it be possible to combine liveness detection with face attribute evaluation on mobile during one auto capture session to get as a result, for example, ICAO compliant liveness image?
Yes, our liveness is designed to capture images that are ICAO compliant. There are some quality validators that only allow such photos to be captured. And the algorithm on the server, out of the 4 images, returns 1 image that is ICAO compliant and can be further used in other processes.
Okay, this one is interesting.
Yes, so that's more or less the same answer as before. So this liveness step can replace the selfie capturing step, because one of the photos which is captured is then returned as the ICAO compliant photo as a selfie.
Okay, so just for the purpose of everybody understanding what the question was, I will read it aloud. So if I understand correctly, the liveness step will replace the selfie step, right? And the answer is obviously yes. Okay. All right, maybe one more question from Uros, and the next we'll keep to answer offline. So is it possible to combine this component with ABIS for face matching at the same time?
Yes, it's possible, because the component returns one image that can be used in ABIS.
All right. And that's it. We have a few more questions, but like I said, we'll get back to you offline. So thank you very much for joining us. Hope to see you next time. And like I said at the beginning, we will be sharing the recording of this webinar with you in the follow-up email, which you will get to your mailboxes definitely by the end of this week. Thank you very much. Enjoy the winter holiday season, and see you next time.
Thank you.